In this lesson, we are going to look at how chemical energy relates to heat and work. We're going to define endothermic and exothermic and learn to convert among different units of energy. Chemical potential energy is the energy stored in the chemical bonds of a substance. Energy can be described as either endothermic or exothermic. In this case, we're looking at the heat energy of a reaction, hence the suffix thermic. Endothermic is when energy is consumed in a reaction, so there is heat going into the system. When we have an endothermic value, it will be a positive numeric value. For exothermic, it's the energy produced in a reaction and heat is exiting the system. In this case, we will have a negative numerical value for an exothermic process. There are different units we can use to describe the energy in a chemical process. The first one is calorie with a little c, so 1 little c calorie equals 4.184 joules. And 1,000 little c calories equals 1 big C calorie. So when you talk about nutrition calories, what they mean is the big C calorie, which is equivalent to a kilocalorie. Notice the lowercase versus the uppercase changes the meaning of the number. So we have calorie with a little c, we abbreviate that CAL. Calorie with a capital C, these are the nutritional calories, so we abbreviate that capital CAL, and a joule, which is abbreviated J. Note that we can use our metric prefixes with these units, such as kilocalorie or kilojoule. Let's look at a problem with the conversion of units of energy. A regular sized pack of M&Ms has 240 calories with a big C. What is the equivalent in units of joules? Just like any other dimensional analysis problem, we need to figure out what we know and what we're trying to find. We are given 240 calories with a big C, and we're asked to find joules. We're going to start with 240 calories with a big C. It's a simple unit, not a conversion factor, and it's the only number given in the problem. Now that we have a big C calorie in the numerator, the next step has to have the big C calorie in the denominator, and 1 calorie with a capital C is equivalent to 1,000 calories with a little c. So units of cals cancel. Next, I have little c calories that needs to be in the denominator, so it will cancel. And 1 little c calorie is equal to 4.184 joules. So little c calories cancel. At this point, I'm left with units of joules, which is what I'm being asked for in the question. I do the math and find that I have 1.00 times 10 to the 6th joules. A reaction consumes 325 kilojoules. How much energy is this in calories? Note that this is little c calories. Again, we're only given one value in the problem, and it is a simple unit, so we're going to start with 325 kilojoules. We know kilojoules needs to go on the bottom, and we know that 1 kilojoule is equal to 10 to the 3rd joules. Remember our rule for metric prefixes: put the 1 with the prefix, put the meaning of the prefix with the base unit. Kilojoules cancels. Now we need to put joules on the bottom, and we say 4.184 joules is equal to 1 little c calorie. Now joules will cancel. We're left with units of little c calories, and when we do the math, we get 7.77 times 10 to the 4th calories.